Let's depict the Lewis structure of H2O, also known as water. To draw an accurate Lewis structure for H2O, follow these steps. Begin by sketching a rough outline of the structure. Illustrate the chemical bonds between the atoms. Mark lone pairs on the respective atoms. Ensure the octet or duet is complete for both the central atom and other atoms. Wrap up the process by calculating formal charges, aiming for a stable Lewis structure with minimal formal charges. To draw the rough sketch of the structure, calculate the total valence electrons first, and then identify the central atom. The total valence electrons in H2O are determined by adding up the valence electrons of each atom. In H2O, there are 2 hydrogen atoms, each belonging to group 1 and contributing 1 valence electron. Additionally, oxygen, a group 16 element, contributes 6 valence electrons. Therefore, the calculation for valence electrons in H2O is 1 for hydrogen multiplied by 2 plus 6 for oxygen, resulting in a total of 8 valence electrons. When determining the central atom for H2O, place the element with the lower electronegativity at the center. In the case of H2O, hydrogen is present. However, assuming hydrogen as the central atom is not valid, as the central atom should typically form bonds with at least 2 other atoms. Since hydrogen usually forms single bonds, due to having only 1 valence electron, it is less suitable as the central atom. Therefore, in the case of H2O, place oxygen at the center and 2 hydrogen atoms on either side. 2 electrons form a single chemical bond. Thus, position 2 electrons on the left side to signify the chemical bond between oxygen and the first hydrogen. Similarly, position another 2 electrons on the right side to depict another chemical bond between oxygen and the second hydrogen. Consequently, of the 8 total valence electrons, 4 are used, leaving 4 electrons unutilized. Lone pairs are electron pairs not utilized in chemical bonding. Remember, each pair comprises 2 electrons. With 4 electrons, 2 electron pairs can be formed and marked on the structure as lone pairs. Also, remember that hydrogen is a period 1 element and cannot hold more than 2 electrons in the valence shell, while oxygen, a period 2 element, cannot accommodate more than 8 electrons in the valence shell. Another key point to remember is to always start by marking lone pairs on the outside atoms and then mark the lone pairs on the central atom. In H2O, the 2 outside hydrogen atoms won't get any lone pairs as they can't hold more than 2 electrons. The central oxygen atom will get 2 lone pairs. Just mark them on the oxygen atom. For the 2 outside hydrogen atoms, the duet is complete, and for the central oxygen atom, the octet is fulfilled. Both the duet rule and octet rule are satisfied. Now, check the stability of the structure by calculating the formal charges. Use this formula to calculate formal charges for the H2O Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Input the data and place the values to determine the formal charges for each atom. For each hydrogen atom, valence electrons are 1, non-bonding electrons are 0, and bonding electrons are 2. So the formal charge will be equal to 1 minus 0 minus half times 2, which equals to 0. For oxygen, valence electrons are 6, non-bonding electrons are 4, and bonding electrons are also 4. So the formal charge will be equal to 6 minus 4 minus half times 4, which equals to 0. The formal charges of hydrogen and oxygen atoms are both 0, confirming that this structure is stable. Thus, this is the preferred stable Lewis structure of H2O. To represent a pair of bonding valence electrons, draw one horizontal line. Since there is 1 pair of electrons on each side, draw one horizontal line on each side, signifying that oxygen forms a single bond with 2 hydrogen atoms. That's the Lewis structure of H2O. If this explanation was helpful, press the like button. Share this video with others and subscribe for more chemistry content.